dynamic relationships. They're always evolving. And one of the key features of it is that it's self-regulating. So when something bad happens, it can set itself back to normal, to homeostasis. So you all are good examples of a living system, right? So the problem with that is non-living systems can't do that, right? Like a computer. They kick ass. But if I was to take that iPhone and I was to dash it on the floor, all its parts would be taken apart, but they could not reassemble. It's like Humpty Dumpty, right? It can't be put back together again.
But what if it was the Iron Giant?
It is not real, and you need to be back in reality, Adam.
Okay.
Stay reality focused. Self-regulating is pretty important. So one of the things we know from living systems theory is that the parts are important, but it's not as important as the whole and how it operates as a whole. All the parts are needed to reach optimization, but they can still, a living system can still function with some parts missing. I'm a good example of that. We've got some parts missing. Yep.
But you don't really need those.
And, a little bit of cartilage here.
Oh, yeah.
Tonsils gone. Some of them aren't necessary. And same with this environment here. It's resilient that way too. If you take away some of the parts, it can do okay, but it's not optimal. All right, let's go take a look at a watershed and talk about how that fits in this idea. We're walking that way for a few moments until we get to an access point.